Hello and welcome back to another video. In this problem, we're told that the monthly cost of driving a car depends on the number of miles driven. Lynn found out in May that it cost her $380 to drive 480 miles, and in June it cost her $460 to drive 800 miles. So in part A, we're looking to express the monthly cost as a function of the distance driven. So C equals cost, D equals distance, and we have 2 points of reference here. So we know that it costs $380 for 480 miles. So that is going to be a point of our function where it's D is the x variable, 480, and cost is the y variable, 380. Why is it not the other way around? Because it's C as a function of D. So C is the dependent variable, just like y would be in an xy situation. And in June, 800 results in $460. So we're going to assume that it's a linear relationship. So we're first going to find the slope. That is the change in y, 460 minus 380, over the change in x, 800 minus 480. 460 minus 380 is 80. 800 minus 480 is 320. Therefore, the slope is 1/4. We can use this to find the y-intercept. The equation of a line is y equals mx plus b. Our slope is 1/4, so y equals 1/4 x plus b. 380 is our y value, is equal to 1/4 times 480 plus b. I should have used C and D here, but it's okay. 380 equals 1/4 of 480 is 120 plus b. Subtracting 120 from both sides, we get b is equal to 260. Therefore, not y, but c is equal to 1/4 the slope times d plus the y-intercept, 260. This is our function. In B, we're asked to use part A to predict the cost of living of driving 1,500 miles per month. So therefore, C is equal to 1/4 times 1,500, since it's the particular distance, plus 260. 1/4 of 1,500 is 375, plus 260 is 635. So $635 per month. In part C, we're asked to draw the graph of the linear function. So we have 2 points here. We can actually start it, not at one of these 2 points, but at the y-intercept, 260. So for 2, 4, 6, 800, 2, 4, 6, 800. So each of these ticks are 200. We're starting at 0, 260. And we are finishing at 800, 460. So this point should actually be down there. And this point will be roughly around there. And it goes a little something like this. And note that I'm starting here, I'm not going into the negatives because you can't drive negative miles. The slope represents the rate of change of C over D. So it's the change in C cost per D mile driven. Okay. Separate all these out so we have space. In D, what does the C-intercept represent? It's C when the other variable, D, equals 0. So the cost for 0 miles driven. And E, why does a linear function give a suitable model in this situation? Because the increase in cost per mile is dependent on gas, right? That is the primary cost for driving more miles. So this is dependent on gasoline. what happens is that you start out with $260. This is car payments, car insurance, whatever. This is the upfront cost. And then for every mile you drive, you spend $0.25. What is that going to? Primarily gas. Or another thing, which is dependent on the miles driven, like car maintenance, which has to happen every so often with a certain number of miles. So it's linear because as you go up in miles, it goes up in sync with those miles. So that's part A, B, C, D, and E for the monthly cost of driving a car.